So for the very first item, which is nothing but 1, right? So it says I comma 0, that it is the 0th index, right? So from 0 and I comma 1, it's height 1. So this is nothing but the 1 comma 0, right? So it has given it as 1 comma 0, and it has drawn this height from here to here. Similarly for 8, it is like 1 comma 8, right? So on the this is considered 1, and this is 1 comma 8, right? So this is what they have delivered it. Similarly for the second one, 2 comma 6. So this was 0, this was 1, this was 2, and this was 6. So 2 comma 6, they have drawn this way, this particular line. Now what is the question? So now they're saying find two lines. So they're saying us to find any two lines together with the x-axis forms a container such that the container contains the most water. So we need to find out two lines which kind of making some container, and that container should hold the most amount of water. And then what we need to do, we need to return the maximum amount of the water a container can store. So we just need to return what will be the maximum amount of water. So let's go through the example as well. So on this particular given input, what they're saying that maximum output will be 49. Why? Because they're saying if they choose this the first index input, which is the 8, and 1 2 3 0 1 2 3 4 5 6 7 8, the 8th index, which is the end of the array, if they are choosing these two, then they are forming a container which will hold the maximum amount of water. So how they are calculating it? So they are calculating it based on so the maximum amount of area, how that can be contained, the height into the width, right? Or we say, let's say the length and width, right? So the length has been replaced here with the height. So how this is coming? So they are basically calculating it. If we see it here, right? So width is nothing but the 8th index, which was the 8 minus the first index, which is 1. So it is coming as 7, right? Now similarly, how they're calculating height. So height on the very first index we had 8, and the last index we had 7, right? We had 8 and 7, but how if we choose the 8, right, the water will overflow. So min of both two they have chosen, right? So they have chosen min of these two, so which is nothing but 7. So that's why our area of this container which will hold how much water is 7:7, which is nothing but 49. So that's why our answer is 49 here. So now let's go ahead and quickly see what all option we can do here. So what if, let's say, instead of, so this is like one of the brute force approach which we can choose here is we can calculate all the formed area, and whatever the maximum area is coming, we can choose that. What do I mean by that? Let's say if I'm starting from the index 0, like I can choose 2 pointers or 2 pointers I and j, like 2 for loop will run and calculate all the possible area, and then the maximum possible area we can choose. So for the very first one, for this one area, what will be the answer? Or the width will be 1, like 1 minus 0 1, and the height will be the 1. So 1 comma 1 will be 1. And then similarly for this one, it will be 2 comma 1 2. Similarly, like, because the min height we are going to choose, so height will always be the 1 for us if it is the minimum looks like. And then the maximum, if we go here, right? So in this particular scenario, it will be 7 if we are choosing. So the outer loop if it's 0, right? So that the maximum area we can choose for this particular scenario is 7. Similarly, if I goes to 1 here, right, in this particular scenario, what will be that? This will be the area 7 comma 1 7, right? 7 comma 2. So 7, not 7 exactly. This will be the 6,16. In this scenario, it will be 2,24. So in that scenario, if you're going till the end, right? If you're coming here, let us see if this is the maximum area or not. So here, what will be the answer? Since both are 8, right? So we will have the 8 multiplied by how much? 0, 1, 2, 1, 2, 3, 4, 5, 6. So 6 minus 1 is 5, right? So 8 by 5 is 40. So our answer would be 40 is the maximum, if the ith like I pointer is on the first array. If it goes to the end, we just calculated it is 49. So our max area will be 49 in this particular scenario. Similarly, I'll be moving to the second item, the 2, and we'll be calculating all. So this scenario will, this scenario will take the big O n square, like our runtime complexity will be big O of n square, right? And space complexity is again since we're going to store all the area, so that will be big O of n. Like we're going to store all the area and then we'll be calculating the maximum area. Or if you're not going to store the maximum area, we're just going to replace the maximum area, right? So space will be big O of 1. But the runtime complexity will go to the big O of n square. If you quickly want to write that, we can do that. Let max area as a 0 and then start 2 loops, right? Or let I equals to 0, I should be less than given input HEI height dot length, comma I plus plus, and then another loop would be to start from the J. Let J is equals to, we can start from the whatever the current plus I plus 1, right? So J is equals to I plus 1, J should be less than height dot length, comma J plus plus. And then the only thing which here we need to do, we need to update our max area, right? So how we are going to calculate the max area? The basic way to calculate the max area is that length into width or height into width. So we have to choose the max area between the current NO and the existing whatever the max area we had. So first we can pass the max area, and second let's calculate our current area, which would be nothing but math.min and our heights. So heights of I, comma j, right? Whatever the minimum area is coming, we'll be choosing that. And then we'll be calculating the width, right? Into index is j minus I, right? If you do this, just see the curly brackets are closed properly. If you do this, we are just updating our max area here. So this is the way to do that. And at the end, we can just return this max area after the for loop. So this is the one way which will have the big O of n square runtime complexity, and space is the only big O of 1. So now other approach could be, since we are using 2 pointers I and j, and instead of both starting from the start, what we can do, one approach we can follow here, we can choose our pointers. So one pointer we can start from the start, and one pointer we can move start from the end, right? So now we know our width is nothing but let's say in this particular scenario 8 minus 0 would be 8, and then we just need to calculate the minimum height, right? So for the very first time our height will be 1, so 8 into 1 would be the 1, right? So our max area we just got 1. And now the problem occurs, we are just going to decrease our pointer, right? 1 by this way, from the left to right or right to left. So we have two set of problem, which one to kind of go ahead and decrease it. So for that, what we can see which one is going to give us the maximum profit. So let's say in this particular scenario, if you're going to decrease the left pointer, so which was having the minimum value, right? So if we see, we'll figure out, the key thing is moving the longer side inward is completely unnecessary. What do I mean by it? If you're going to move this one inward, the right index, right? That is unnecessary because our height is basically dependent on the minimum area, not on the maximum. So let us quickly see that as well, what happens. So if you're going to move the ith pointer to, let's say, the index 1. So now our value is nothing but 8, right? Here. So now let us say our height would be what? Our height would be min of 8, 7, which should be 8, right? So now our height has got, initial our height was 1, now our height has got updated to 8. Now what about our width? So width is going to decrease, right? So 8 minus 1, which is nothing but 7, right? So now our max area, whether it's going to update it or not. So in the first instance, it was 8 minus 1 was 8, right? Now our max area would be what? Height into width, which is 8 into height would be what? 8, and then this was 7. So height would be the 7, right? The minimum one. And then the width was the 7. So 7 into 7, which is 49. So we got, the max area got updated. So when we are kind of moving the smaller pointer inwards, our, the max area got updated. Now, what if we choose to move the larger value to inward section, right? What if we do that? So let us see. So if we move the j pointer to the index which is named as 0, 1, 2, 3, 4, 5, 6, 7. So j will get updated to the 7th one. So what will be our height? So in this particular scenario, since we are moving and the value is getting decremented, right? Instead of increasing, the value is getting decremented. So our height got decremented, right? But what will be the min of these 3 and the current min which we had here? So which is nothing but the existing min, right? The very first one. So our height will still be the 1. What about the width? So width, the value got decremented here, right? Earlier it was 8, now it is 7. So now our max area is what? It is same, right? What we got earlier, which is 7 into 1 is 7. So it got less than, the earlier maximum area. So earlier we had, the width was 8 and max area, the height was 1. So 8 into 1, so 8, right? It was 8. So we are not going to update our max area from the 8 to 7, right? We'll be ignoring the coming, whatever the area is coming. So in this particular scenario, we found if you're moving the right area, the larger value inward, right? Our max area is not going to be impacted. So now there is one more scenario. If we are moving our right block, the right area, right? The right index inwards, instead of decreasing the value, what if we find the value anything, let's say the 9 instead of 3? So let's just quickly see that as well. What we can see, so another thing, like another use case, what if the value of j got decremented? So now the value of j is 7, like index is the 7, but the value instead of 3, let's say the value got updated more than 7, right? Which is nothing but 9. Let's assume it's 9. So what will be the height in this case? So height, even the values got updated to 9, right? Our height won't upgrade to 9, right? Because we're going to check the min of whatever the current 1, and then let's say 9. So our height will be 1 again, right? And what about the width? So width got decremented. So width from 8, we have chosen 7, right? So 7. So now what is the area coming? It's coming as 7 is to 1, which is nothing but 7, right? So our max area won't be updating because previously our max area was 1 into 8, 8. Now it got decremented. So even though if we saw, we are going to move the larger value, right? We are going to move the larger value, even if the value is either here getting incremented or decremented. If the value is getting incremented here or decremented, our area, the max area is not going to be updated. Oh, it's going to be decremented only. So the only use case which we found, if we like move the left value, which was having the lesser the value inwards, then only we are going to get the maximum area sometime in the future. But if we are going to decrement the pointer which have the maximum value, if we are going to decrement them, then our area is not going to be impacted because we are decreasing the width. And even if the, let's say we are going to find the next area, which is like the maximum, like the greater than or lesser than that, our area is not going to be impacted from that. Cool. So that should be the approach which we have to follow. And now let us go, and try to write this solution for the same which we discussed here. So now let's initialize our pointers. Let I equals to 0. Let j equals to our input array, right? HIGHT dot length -1. Then let's have a max area as 0 as now. Now, when should we close this loop? When I is less than j, right? So as of now, our assumption is we are going to move this pointer from left to right and then from right to left. The moment our pointer intersect each other, we are going to close our loop, right? So now, what is the current thing? So to calculate the area, we need to find the height and width, right? So let's check. So we already have this height, the input variable name as a height. Instead of doing that, let's say it's a length. So length into width we can do. So let length is equals to, how we are going to find it, math.min, right? Because whatever the two value, we have it here, we are going to choose the minimum out of these two. So math.min, height of I, comma height of j. So this will be our length. What about the width? So width will be nothing but, the indexes, the difference between those indexes. So j minus I, right? So this is the width. Now let's calculate the current area. So current area is nothing but now length into width, right? Now let us see whether we are going to update our max area or not. So we'll just see max area would be what? Math.max, whatever the maximum value, from our max area, comma, whatever the current calculated area is coming, is just going to update that. Cool. Now, so we just calculated the area and updated our max area. Now the next problem for us was, to move the pointers. Either we are going to move the left pointer or the right pointer. So what we discussed, we are going to move the pointer which have, the lesser values. Then only we are going to get, the maximum area in the future. So to do that, what we can do, if height of I is less than, height of j. If that is the case, so that means, let's say that this value is lesser than the last one, right? So we are just going to move our left pointer, which is nothing but the I plus plus. Else, if that is not the scenario, that means the right pointer had, the lesser value. In that particular scenario, we are going to move our right pointers inwards, which is nothing but j minus minus. Now, if we are done with all these calculation and our pointer crosses each other, right? So we have come towards the inward like the sink. Then we will have, the maximum area into this max area variable. So we just need to, after this loop, return this variable. Cool. Now let's go ahead and submit it. We'll see whether we are going to return it. So yeah, the solution got accepted, means whatever the all input scenario were there, it got, successfully. So now let us see the time complexity and space complexity for this particular scenario. So what will be the time complexity? What we are doing it? We just initialize two variables, and we are going to read each input indexes only once. So the index I, the variable which we have, it is going to read from the start, and it will, let's say, read till here, right? and then the index j is going to read till here. So in that scenario, we are covering each index only once. So that is the time complexity would be big O n. What about the space complexity? So space complexity, if we see, we are just storing, all those values into this data named as the strings only, or the the numbers only, right? So we don't have an array involved here, which is going to store all those till the length of the input array. We're going to store all the variables. We are not doing that. We're just storing all the numbers into the static variables. So that means the space complexity would be big O of 1. So this approach is basically called the two-pointer approach, and this has basically been this has helped us to find container with the most order. Cool. So that's all for this particular video.